Hi, welcome to Resin Chem Tech. Do you like LED lighting? Obviously, I do. Now this is a little bit crazy and over the top, but this can be toned down and used just for ambiance lighting. But if you're interested, today I'm going to talk about how you can build your own LED light strip controller for a little less than $6 and about an hour to hour and a half of your time. It'll have thousands of colors and hundreds of different effects that you can use anywhere in your house. So stay tuned. So a little bit over the top? If you thought so, my wife would not disagree with you. So why would you want to build your own light strip controller when you can buy ones that come with a remote control? Well, the one thing is this remote control is going to be somewhat limited in terms of the effects and how you set it. And in all honesty, I haven't had a lot of luck with these IR remotes. You've got to get them really close to the transmitter. So the one we're going to build not only will be available over Wi-Fi, but of course we're going to be able to integrate that into Home Assistant, control it, and use it for automations. We'll talk about the parts, the assembly, and putting WLED on our controller. Okay, here are the parts we're going to need to build our WLED controller. Now note that there are a lot of different options, different ways to accomplish this same thing. This is the way that I build mine, and I build it primarily to be as small as possible and as reliable as possible. But the first thing we're going to need is an ESP8266 board. In this case, I'm using the Wemos D1 Mini. If I can get that up here and get it focused. Again, I like this for the small size, reliability, and honestly, we're only going to use one and optionally two pins other than the 3 volt, 5 volt, and ground, 3.3 volt and ground. So, a bigger board with more pins is really not needed in this particular case. The other option, or not an option, but the other thing we're going to use here is a logic level shifter. I'm going to get that up there and we can see that. So what it will do is it will take the 3.3 volt signal that comes out of the D1 Mini and shift it up to 5 volts. The reason we need to do that is even though the D1 Mini runs off of 5 volts, the output of the pins are only 3.3 volts. And our LED strip, WS2812B, expects a 5 volt signal in. Now, you can get away with using the 3.3 volt signal if you have the strip installed very, very close to your controller. The 3.3 volts is barely enough to go ahead and send that signal through. But if you're going to have any kind of distance in there, you're going to need to boost that signal to 5 volts. There is an alternative to using this logic level shifter, although I will say that the logic level shifter will cost you about $1. And it's a much more reliable way, and it can actually output multiple channels. Get that back up there, get that focused. So in this case, I think it's 4 channels that you can shift up. But the alternative is to simply take a single pixel from one of your strips, cut that pixel off, and use this as your logic level shifter. So we would install a single pixel really close to our board, and we would run our 5 volts and our signal through this, and then we would run out to the rest of our LED strips. So that is an option. It does require a little bit more soldering. In the WLED software, you can actually disable this first pixel if you want to do it that way. And of course, you can go with a full Node MCU ESP8266 board. But again, that's going to make our overall size much bigger. The goal here is when we're done, we're going to mount this on an Electro Cookie prototype board, which will allow us just enough room to mount our control board and our logic level shifter. And then that will then fit into this small 3D imprinted closure. If we end up going with the Node MCU, which again is really kind of overkill. We don't need all these additional GPIO pins. But if we do that, we have to move up to a bigger board and a bigger enclosure. So just for comparison's sake, here are the two different sizes. And by using the Wemos D1 Mini, we can significantly make a much, much smaller controller. And of course, there are some optional items. You're going to need obviously some wire. I recommend either some spade connectors, or you can use these JST connectors. You can directly solder everything right from your board right to your LED strip, but I like to, it makes installation much more difficult, so I do like to have connectors where I can build my controller, install my LEDs, and then basically connect everything together. Another option I like to use is a push button, a simple normally open push button. WLED has the ability to control the lights locally. So I have the ability to turn the lights off and on, change effects, single press, double press, long press. So I like to install what I always call a muggle button, a way to control the lights locally through a button push without the need to even use any kind of automation. So I will show how we install that as well. I think that's it for the parts. So obviously we have to solder these pin connectors or pin headers onto these boards. That is one advantage of the Node MCU, is it comes with the pin headers already installed, but you sacrifice that for the size, and but you do save yourself a little bit of soldering. But this is a really good project. If you're not really excellent at soldering, this is a really good project to kind of hone your soldering skills, because it really is pretty simple. So we'll take a look at that next. Okay, the first thing we need to do is we need to solder our pin headers onto our Wemos D1 Mini and our logic level shifter. Now note that, because again we're trying to keep this small, and due to the size of this electro cookie, there's not quite enough room for all 6 of the pin headers on the logic level shifter. So we'll actually just be using the 5 pins, 5 most innermost pins. But also note that you want to assure that you've got the low voltage side on the same side as the 3.3 volt on the D1 Mini, and the high voltage side on the same side as the 5 volt. So again, we're going to break pins off, and we're not going to solder a pin on this very first channel of the logic level shifter, but that's fine. It still leaves us 3 other channels that we can use. Now I found the easiest way to solder these headers onto here and assure that your pins stay straight, because you notice there's some play in there, is to simply use a breadboard. So we're just going to insert the pin headers into the breadboard. Make sure we get those lined up right. And again, for this, we only want to use 5. So we're going to count 1, 2, 3, 4, 5. We're going to break off the pin headers there. And we'll stick those in here. And then 5 for the other side. 1, 2, 3, 4, 5. Break those off. 5 over here. Now we can drop our boards on top of these pins. Well, except I got one row off there. It's kind of important to make sure you get the right spacing between those. There we go. We'll drop those on there. Again, drop this on here, making sure that we're leaving this last pin blank, and then we just start soldering. Oh, first of all, I'm going to turn on my exhaust fan. It's important to make sure you have an exhaust fan. I've got myself a little home-built exhaust fan here, made from an old PC fan, and believe it or not, this is another WLED install. It actually gives me some extra lighting here. So, all right, let's start soldering. Now, I do like to use a little bit of a no clean flux. I find this just makes things a little bit easier to solder. So we're just going to apply a little bit of flux to these pins. And we'll take our soldering iron and get started. So while I'm fast forwarding through some soldering here, I want to make an editorial opinion that, I've opted not to monetize my channel. Of course, I'm not eligible yet, but one thing I like is the fact that I don't get ads on my videos. But YouTube has changed their terms of service and reserved the right to serve ads on any videos. So if you're seeing ads before, during, or after my video, I apologize. It's out of my control, and I receive no income from that. So just be aware that I have no control over these ads. There we go. Again, no pin on that last piece. So now we just pull these out of there, and you'll notice our pins are nice, straight, and aligned, and they're now ready to fit directly on to our prototype board. This is the wiring diagram we're going to follow. Now note that the Electro Cookie Mini board does have the advantage of having columns connected on each half of the board, but unlike a full breadboard, it doesn't have a power rail on each side. And since we're going to need multiple ground connections and power connections, we're going to have to solder some additional connections in these columns, which will be underneath the mounted ESP32 or the D1 Mini and the logic level shifter. So we're going to do all this wiring on the underside of the board, and some of the wiring is going to need to be completed before we solder our logic level shifter and D1 Mini to the board. And I list down here what I recommend you solder prior to wiring you do prior to soldering the boards on and then after. But we're going to have 5 volts coming in from our external power supply, and the logic level shifter is going to need 5 volts on one side and 3.3 volts on the other side to shift that signal out to our LED strip from 3.3 volts to 5 volts. So let's take a look at how we soldered this board. Okay, next we need to solder some jumpers on our board, because if you remember from our diagram, we're going to use some of these connectors that are underneath the D1 Mini. So we need to make these solder joints from the bottom of the board, and we need to make them before we solder the D1 Mini onto the board. So I went ahead and cut my jumpers here. I'm using 20 gauge solid wire. I like to use solid wire for this just because it's a little bit easier to bend and hold into place. So we'll check our diagram here, make sure we get everything in the right spot. This is going to be our 5 volt connection to our high side. Yep. And our ground to our logic level shifter. And then the ground to the other side. It should go right here. Get that in there where it belongs. There we go. So we need to solder these into place before we flip this over and put the D1 Mini into place. Now, you can use blue tack, you can use a lot of different ways. I just like to throw a little masking tape on there to make sure I'm holding these into place so I can flip it over. The only other thing to note here, I don't know how well you can see this, you want to make sure that these wires are cut fairly short. You want them barely protruding through, because this is going to mount on top, and we don't want the tops of these coming into any contacts with anything underneath here. So you need to make sure that those are short, and when this board goes into place, masking tape's in the way, nothing's going to touch. If you get them a little bit too long, you can always trim them off, but you want to keep these wires coming through here fairly short. All right, let's solder these into place. If you're new to soldering, there are lots of YouTube videos that will give you tips on soldering. But the most important thing is a good soldering iron. Make sure your tip is pre-tinned and flux is your friend. So there we are. Our next step is going to be to go ahead and solder these onto the board. But before we do that, I like to go ahead and install the WLED software onto my D1 Mini. So in the past, until very recently, the only way to install WLED was you had to go to the GitHub, go into the latest releases, figure out which binary that you needed, download it, and then use a third-party utility like ESP Home, Tasmatizer, or something else on your machine to upload that to your board. But just recently, AirCookie has added a way to install WLED directly from your web browser. All you need to do is identify the COM port when you plug in your D1 Mini, and it doesn't show here because it didn't record the pop-ups on this screen, but you can go to Control Panel in Windows, plug in your board, and look to see what COM port pops up. In my case, it happened to be COM port 8. So once we know that COM port, you plug it in, simply hit the install button. Another pop-up is going to ask you to verify the COM port. You select the one you know, and boom, it starts installing. It's that easy. No downloads, no third-party utilities, nothing like that. It's going to install the latest version of WLED, and it's also going to detect whether you have an ESP8266 or an ESP32 board. So this is outstanding work. It makes installing WLED much easier and quicker. While this is installing, I'm going to give a shout out to Air Cookie. That's the handle the developer of WLED goes by. And if you find this useful, he has spent a lot of time developing this and continues to develop this and gives it away for free. So if you do find this useful, go to the GitHub webpage. By the way, I'm going to leave links for everything down in the video description to WLED, also to my blog that has all the details for the diagrams and the written steps to create your own controller. But back to the point, go to Air Cookie's website. He has a link at the very bottom of the welcome page, and if you can find a way to throw him a few dollars in terms of a donation via PayPal, please do that. Those of us who use anything with LED strips or Home Assistant, you've heard of WLED, and Air Cookie has done such a fantastic job. I really would hope that you could support his work by, throwing him a small donation if at all possible. So again, this only takes a few minutes, maybe 60 to 90 seconds total, and boom, we are installed. Okay, now that we've got WLED flashed onto our D1 Mini and connected to our Wi-Fi, we're ready to go ahead and solder this and our logic level shifter onto our board. So we'll take our board here, and if you're following along with the diagram here, notice that the first pin here are actually set up to be in column 2 of the board here. That should line up on the back side, our 5 volt and our grounds lining up right here with pin 1 and pin 2. So double check that. And then for our logic level shifter, should fit right in here. And again, you notice that we did not put the pins here because they're actually going to overlap the board. The other thing that you want to check and verify is make sure that the LV or low voltage side is on the same side as the 3.3 volt on your D1 Mini, and the high voltage should be on the same side as the 5 volt. Okay, so we've got those in place. Thing is there. So we're going to use the same technique before. I like to use a little masking tape here to hold things in place. This on there. We'll flip this thing over and we'll start soldering. Okay, looks like everything should be soldered on there good. Take this off. And we have a couple more jumper wires to install here. We still need to run the 3.3 volts out here to the low voltage side of our logic level shifter. And we still need to take our actual signal that's going to go out to our LEDs and run it through the logic level shifter. So again, following along with the diagram, need one here. There. This one can be a little bit trickier to run. How did I do that before? So we're going to go into 4 here. We're actually going to run between the pins. And there's a hole right there. Okay. A little tape. And solder those. Okay, the only thing we've got left to do now is we have to solder our few leads coming in for our 5 volts coming in, our signal LED signal going out to our LED strip, and optionally, which I'm going to go ahead and do here, is leads to a couple of push buttons. So as I fast forward again here through some soldering, I want to reach out and ask you, the viewer, about what kind of videos would you like to see in the future. Do you prefer these full 30-minute how-to videos from start to finish, maybe with chapter breaks so you can jump around? Or would you rather see the short highlight, 8 to 10 minute videos with maybe a link to a blog post that has the full details? I'm specifically interested in those of you who have been kind enough to subscribe to the channel. I'm a relatively new channel, so I'm kind of looking for feedback on what kind of things do you want to see me do in the future. If there's anything from my smart home tour you want to see more details on, please post it down in the description, or the comments to this video, and let me know. Okay, that finishes all of our soldering, so we can turn our fan off here and get rid of that noise. Take this off. Everything is soldered together, holds good. So now what we're going to do is we're going to throw it in our 3D printed enclosure. Once again, as I work to throw this in the enclosure, I just want to mention the huge advantage of a 3D printer. If you're into DIY electronics or home automation, I can't emphasize enough the utility of a 3D printer. And to be honest, the cost of these come down so much. If you can see here that you can currently get a 3D printer for as low as 155 bucks, and you may even be able to find a better price than that. But having these available will make so many of your projects better. And of course, you can find copies of these kind of things on Thingiverse, and you can design your own on Tinkercad. It's really a great investment. And there you go. So we've got a WLED controller with optional push button control over here, our signal wire to our LED strip, and our 5-volt power in. One thing I did want to mention is you could theoretically power this thing off of the USB and not have these leads to your 5-volt power supply. However, if you do that, you have to run a ground from your 5-volt power supply that's powering your LEDs to the ground on this board. You have to have a common ground between your board and your LED strips, or things will not work well and be really funky. So I usually just go ahead and power this off my 5-volt power supply. It's instead of having a USB cable and having to have a USB plug, but that is an option to do that. But a lot of people will discover when they do that and power this off USB, if you don't have that common ground wire connected to your LED strip, then all kind of funky things are going to happen, and it's just not going to work for you. All right, put this back together, and we're ready to hook it up, and we'll do a quick bench test. Okay, I've tried to clear things off a bit here, set up for a bench test. It looks a little bit crazy in terms of wiring, but again, this is just a temporary hookup. So real briefly, over at the edge of the screen is our 5-volt power supply. We're running, again, our 5 volts from our power supply into our controller board. We're also running separate 5 volts into our LED strip. Here's our green signal wire coming out of our control box, which is running the signal in on our LED strip. And then finally is this optional button, and we'll give that a test in a minute. But we want to make sure we've got nothing touching here, and we'll plug in the power supply and keep our fingers crossed that everything works. Okay, there we go. Now by default, the first time WLED starts up, it's only going to light up the first 30 pixels in orange, and it looks like that's just about where we're at here. So what we're going to do now is we're going to go ahead and connect to this and make sure we've got control. I'll try to throw this up here on the screen and see if we change to blue. Let me turn this other light off and see if we can see things a little bit better with not quite so much light there. Blue. Got red. Let's try a couple of effects here. Yeah, that's not a very good one. Blink. Okay. And we'll just go over here real quick into the well, you can see this into the config, LEDs, and even though there are 300 here, power supply is probably not enough for that. Let's just set it to 100 for now and save. Let's go back to solid color here. Yep, it looks like everything is working. So let's test our button. By default, you can define what these buttons do. Now it looks like we have a problem with the button. Okay, figured out what the problem was with our button. This new version of WLED actually allows you to define the pin settings, and it's a little hard to see here, but you actually define, it's going to be hard to see and get focused, but you define which pin your button is connected to, and I hadn't defined that. So once I found that setting, went in and basically said this is hooked up to D3, which is GPIO 0. Now when we push our button, we're able to control the lights, long, double press. There you go. So our button's working. Let's turn those back on. Our control's working. Everything seems to be good to go. So we're ready to install this in whatever installation we want to use it for. So that'll do it for this video. If you found it at all useful, go ahead and hit that like button to let both me and YouTube know that you like these types of videos. And if you want to see more of my videos, be sure to click that subscribe button down here in this corner. And if you want to be notified whenever I release a new video, go ahead and click that bell icon right next to it. So as always, thanks for watching. We'll see you soon.